Hi everybody. In this video, we're going to talk about angles and transversals. So let's begin. First, definition of parallel lines. Parallel lines are lines that are drawn in the same direction. So for example, in this picture here, the blue lines are parallel because they're both going in the same direction. All right. And a transversal is a straight line that intersects two parallel lines. So in this picture, this black line over here is a transversal because it intersects these two the two blue lines which are parallel. All right. Now, continuing, just a couple of more definitions. Congruent angles are angles that are equal to each other, so keep that in mind. Congruent means equal. Complementary angles are angles that add up to 90 degrees. So for example, if we had two angles and one of them was 25 degrees and the other one was 65 degrees, you add 25 and 65, you get 90. So those two angles would be complementary. Okay, we're actually not going to be using complementary angles at all, really, but there's the definition. Here's what we will be using. Supplementary angles are angles that add up to 180 degrees. So just an easy example, if I have one angle which is 100 degrees and another angle which is 80 degrees, you add those two angles up, you get 180 degrees. So that means those two angles would be supplementary. Okay, we're doing a lot of definitions right off the bat in this video. So the next one, and then we're actually, I think, going to get this picture over here. Adjacent angles that make a straight angle are a linear pair, and angles forming a linear pair are supplementary. So I have to explain that one a little bit. First of all, what are adjacent angles? Adjacent angles are angles that are right next to each other. That's not the technical definition, but that's the definition that's a little bit easier to understand. So for example, this angle over here and this angle over here are right next to each other. So those would be adjacent angles. Similarly, let's say this angle over here and this angle over here are right next to each other. So those are also adjacent angles. What about this angle and this angle? They kind of look like they're next to each other, right? Would those be adjacent angles? Actually, no, because the definition that I gave you, adjacent just means that they're next to each other. That's kind of vague. Really, if I wanted to be more technical, adjacent angles need to have a common side and a common vertex. So going back to this one and this one, these two angles are adjacent because they have a common side. So this side right over here is one of the sides that makes this angle, and it's also one of the sides that makes this angle. So that is the side which is common to both of these angles. And also, the vertex for this angle would be right over here, and the vertex for this angle would also be right over here. So they also share a common vertex. Whereas these two angles do not share a common I'm sorry, they do actually share a common side. So this angle has this as one of its sides, and this angle also has this as one of its sides, but they don't share a common vertex. Okay, this would be the vertex for this angle, and this would be the vertex for this angle. So these would not be considered to be adjacent. Okay, so, but informally, you can just think of adjacent as meaning next to each other, just a quick informal definition. Now, adjacent angles, so angles which are next to each other and make a straight angle, are a linear pair. So, for example, actually all of the adjacent angles that are in this diagram happen to also be make a straight angle. But if I were to just draw another diagram, for example, let's say a diagram that looks like this, then this angle and this angle, they are adjacent angles, but they don't form a straight angle. A straight meaning if I look at this side of this angle and I look at this side of this angle, this is not a straight line, and therefore these two angles together do not make a straight angle. Okay, on the other hand, if I look at this angle and this angle, they are adjacent, right? They're next to each other. They share a common side and a common vertex. And also, if I were to just draw over, let me do it in a different color maybe. If I just draw over this line, which is the sort of the outside of this angle, and I also draw over this line, which is the outside of this angle, then these two lines together do form a straight line, and therefore these two angles together make a straight angle, which is 180 degrees, okay? So adjacent angles that make a straight angle are a linear pair. So this angle and this one, we would say that they are angles which form a linear pair. Notice the word line in the word linear. All right, and angles which do form a linear pair are supplementary, because a straight line, a straight angle is 180 degrees. From here to here, if I were to take a protractor and measure from here all the way over to here, that would be a 180 degree angle. So I may not know what the measure of this angle is exactly, and I may not know what the measure of this angle is, but I know that together they make 180 degrees, and therefore they are supplementary, because remember, the definition of supplementary angles are simply angles that add up to 180 degrees. Okay, now before I continue over here, let me just write in some angle measures here. Now, I don't have a protractor with me. I could maybe download a virtual protractor or something, but I'm just going to eyeball this, and I'm going to say that this angle right over here is approximately 50 degrees. Okay, so let's just, and you know what, let me use a nice bright color here. Okay, so this angle, right, the rotation from here to here, let's just say that's 50 degrees. Okay, I don't have a protractor on me. It might not be exactly 50 degrees. If you want to maybe have a protractor lying around at home and you want to put it up to the screen, you can see if I'm right or wrong, but it's about 50 degrees. What do I know about this angle and this angle? Well, I know that this angle and this angle together form a straight angle. Okay, these angles are a linear pair. Together they form a straight angle, and that means they must add up to 180 degrees. So if this one is 50 degrees, then this one must be 130 degrees, because 180 minus 50 is 130, and therefore 130 plus 50 is equal to 180. So if I know what this angle is, then I can figure out what this angle is just by knowing that these two are a linear pair and they're supplementary. Okay? And we could use that same argument all around these angles. So this angle and this angle together, they also make a straight angle. That's 180 degrees. You can see that this line underneath them is a straight line. So if this one is 130 degrees, then this one must be 50 degrees. Okay, and we can continue like that. If I know that this one is 50 degrees, and I know that this one and this one, I can see that they make a linear pair as well, then this one must be 130 degrees. Okay, I also could have figured that out starting with this one. I could say that this angle and this angle are also make a linear pair, so they also must add up to 180 degrees. So just by knowing one of these angles, we can figure out all of the other ones around here. Okay, now what about these angles over here? If I know the measure of these angles down here, can I figure out the measures of the angles around here? And the answer is yes, I can. And so notice that, oh wait, I wonder if I can, you know what, I'm gonna do this. Okay, I'm thinking on the fly here. I just had an idea. Wait, how come it's not? Apparently I'm not thinking very well. Okay, now it's letting me. Okay, let me do this, and then I'll be able to move it, unlike this thing over here. Okay, so look at what happens. So what if I wanted to know the measure of this angle over here? Okay, I don't know what it is, but I know that this line and this line are parallel, right? And notice what happens if I just take this line and I move it down here. I know that eventually I can just make it overlap completely with this line, which I will in a second. But right now, I want you to just notice that as I take this line and move it down, this angle between this line and the transversal over here, the angle doesn't change. Okay, well, I didn't do that very well, but the angle is not changing. I can move this down as much as I want, and the angle between these two lines over here, this transversal and this blue line over here, which happens to be parallel to this one, that angle, the rotation between these two lines does not change. And therefore, if I get to, go to the logical conclusion here, what am I going to do? You probably know I'm just going to make this line overlap with this one, and then you can see that this angle, which I had all the way back over here, remember that? It must be equal to this angle, which I had down here. Okay, so this angle up here must be 50 degrees, just like this one. Okay, so I can write that in, and I could use the same argument. Can I erase this now? I don't need this guy anymore. Okay, so I can use the same argument with this thing. So this angle must be the same as this one, and this angle must be the same as this one, and this one must be the same as this one. If I were to take this parallel line and just move it down, then I would see that this angle would go to here, this angle would go to here, and so on. So if I know these angles down here, then I know these also. So this one must be 50 degrees, just like this one. This one must be 130 degrees, just like this one. Okay, this one must be 50 degrees, just like that one, and this one must be 130 degrees, just like this one. And really, all I needed to know was one of them, because if I know one of them, then I could use that linear pair trick that I did a few minutes ago and to figure all these out, and I could do the same thing around here. But anyway, so you can see that this is, this looks exactly like it does down here. Okay, now I also want to show you just some examples of linear pairs where the parallel lines have been drawn differently, because parallel lines don't have to be horizontal, right? They could be, here I have the parallel lines drawn vertically, here I have the parallel lines drawn diagonally, and here I also have the parallel lines drawn diagonally. And I put dots for the angles instead of drawing a line like this. But in any case, so these two would be linear pairs. Okay, these two would be linear pairs. They form a straight angle over here. They're adjacent, they form a straight angle. These two would be linear pairs, right? And these two would also be linear pairs. So just some examples so you can see of linear pairs occurring in other diagrams. Because again, the parallel lines don't always have to be horizontal like they are here. All right, so let's go back over to here, and now we'll talk about some more vocabulary. Interior angles are angles that are on the inside of the parallel lines. So in this diagram over here, here are the parallel lines, which are drawn in blue, and then the angles which are inside the parallel lines would be this one. I'm just going to circle them. This one, this one, this one, and this one. Okay, so these angles over here are inside the parallel lines. Okay, now exterior, so that's a pretty simple definition. This one is also pretty simple. Exterior angles are angles that are on the outside of the parallel line. So again, these are the parallel lines here. The exterior angles would be this one, this one, this one, and this one. Those are on the outside of the parallel lines. All right? So not too hard there. Let's move on to another definition. Corresponding angles are angles that are on the same side of the transversal, with one being an interior and the other being an, oh, what happened to the rest of the definition? I think that's it. There, now I found it. Okay, corresponding angles are angles that are on the same side of the transversal, with one being an interior and the other being an exterior angle. Corresponding angles are congruent. Okay, so for example, you know what, instead of circling them, I'm just going to do a circle is maybe a little bit misleading because a circle is not really an angle. Like from here to here, that's an angle. Okay, so this angle and this angle are corresponding angles. Why? If we follow the definition, corresponding angles are angles that are on the same side of the transversal. So here's the transversal. Remember, it's that line that cuts across or intersects with the two parallel lines. And these two angles here are on the same side of that transversal, with one of them being an interior angle. So this one over here is an interior angle. It's inside the parallel lines. And the other one being an exterior angle. This angle over here is an exterior angle because it's outside of the parallel lines. And corresponding angles are congruent. Remember, the definition of congruent is just that they're equal. So corresponding angles are equal to each other, as we can see from this diagram. They're both 130 degrees. Okay, so if I were to just give you some other parallel lines like this, and I told you that, let's say, this angle over here was, say, 121 degrees. Well, this angle and this angle would be corresponding angles. So this angle would also have to be 121 degrees, all right? Because they're both on the same side of the transversal, with one being an interior angle and the other being an exterior angle. And now I'm just going to give you some other examples, just so you can see them, of corresponding angles, okay? Just with the parallel lines drawn differently. So these two would be corresponding, these two would be corresponding, these two, and these two. You can see in all of the pictures here, here are the parallel lines, here's the transversal. The two angles are on the same side of the transversal. One is an interior angle and the other is an exterior angle. Okay, you can see that. You can pause the video if you want and just take a closer look to convince yourself that all of these pairs of angles here are actually corresponding angles. All right, so now moving on. Now let's get to alternate interior angles. Alternate interior angles are angles that are on opposite sides of the transversal and are both inside the parallel lines. So the word alternate is going to refer to the fact that they're on opposite sides of the transversal, and the word interior is going to refer to the fact that they are inside the parallel lines. So for example, this angle right here and this angle would be alternate interior angles. Alternate because they're on opposite sides of the transversal. Remember, this is the transversal over here. And interior because they are inside the parallel lines, okay? And alternate interior angles, as you can see from this diagram, are congruent. They are equal to each other, all right? And now just going to show you some other alternate interior angles. You can pause the video and take a look at these and convince yourself that they're all alternate interior angles. Okay, so again, here are the parallel lines. They are on opposite sides of the transversal, and they're both inside the parallel lines. Now let's move on to alternate exterior angles. Alternate exterior angles are angles that are on opposite sides of the transversal. Well, that's the same as what we had before, because we had the word alternate there too. But these guys are both outside the parallel lines, and that's because here we have the word exterior instead of interior. But we still have the word alternate, so they're on opposite sides of the transversal. So for example, this angle and this angle, these would be alternate exterior angles. Different sides of the transversal, but and they are outside of the parallel lines, okay? And alternate exterior angles are congruent. Oh, look at how straight that was. I just did that freehand. It's pretty impressive, huh? All right, so they are congruent, as you can see over here, right? These two also, I don't always have to go on the left here, or start on the left. I could start with this one. These would also be alternate exterior angles, and you can see that these are also congruent. They're also equal to each other. All right, and here are some more examples of alternate exterior angles. You can just pause the video and convince yourself that those are all alternate exterior angles. And now I'm going to go back up here. We have just a couple more of these, right? They're not hard. Same side interior angles. It's easy to figure out what it means just from what the name is. So same side interior angles are angles that are on the same side of the transversal, duh, and are both inside the parallel lines. Again, because we have that word interior, so these guys are going to be inside the parallel lines. So for example, these two angles would be, by the way, when I say an angle by itself can't be a same side interior angle. So when I say that these two angles are same side interior angles, I don't mean that this is a same side interior angle and then completely independently this one is also a same side interior angle. What I mean is I'm talking about the relationship that this angle has with this one, all right, and also that this angle has with this one. The relationship of these two angles is that they're same side interior angles, which means that they're on the same side of the transversal. Remember, this is the transversal, and they're both inside the parallel line. And same side interior angles are supplementary, which remember means that they add up to 180 degrees. So here 50 plus 130 is 180. So these would be supplementary. Same thing with these two angles. Here I have 130, here I have 50. Again, they add up to 180 degrees. All right? Now you guessed it, I'm going to show you some more pictures of same side interior angles. So these are also same side interior angles. So for example, here's the transversal in this picture, and both of these angles over here are on the same side of the transversal, and they are inside the parallel lines, which makes them same side interior angles. And I believe now we're up to the last one. Is this the last one? Yes, it is. So same side exterior angles, which you probably guessed. These are angles that are on the same side of the transversal and are both outside the parallel lines. Outside because of the word exterior here. And same side exterior angles are supplementary. So let's do an example of same side exterior angles. How about this one and this one? This is 130 degrees, this is 50 degrees. So these are both on the same side of the transversal. They're both on the right side of the transversal in this case. And they're both exterior angles, which means they're outside the parallel lines, that makes them same side exterior angles. And you can see that they're supplementary because this is 130 degrees, this is 50 degrees, 130 plus 50 is 180. So they add up to 180 degrees, which by definition makes them supplementary. And to end the video, as you guessed, I'm just going to show you a quick picture of, where are they? Of same side exterior angles. So you can go ahead and pause the video and convince yourself that all of these are on the same side of the transversal and they are all outside of the parallel lines. Okay, so that's it. And I hope you enjoyed it. Have a great day.